My name is Alexander Knopp, and this is Introduction to Mathematical Reasoning. In this video, we are going to discuss the core object of the modern mathematics, the notion of a set. A set is a collection of objects such that this collection is well defined. In other words, we can easily determine if an object is within the collection or not. If an object S is within the collection E, we write it like this. If it's not, we write it like this. There are several standard sets we use in practice. The first of them is the set of positive integers or natural numbers. The second one is the set of all integers. The third one is the set of real numbers. And finally, the last example is an empty set. It's a special set because it doesn't have any objects at all. In the case when we need another set, not the listed before, we may use the list notation. In this case, we write something like this. So we write a curly bracket and list all the objects we need to have in the set. So for example, 1, 7, and pi. This set consists of 3 objects, 1, 7, and pi, and nothing else. Or we can write something like this, 1, 2, 3, closing the curly bracket. This set is just the set of positive integers, so it's the same as n. You may also want to describe a set of objects satisfying some constraint. For example, you want to describe all real solutions of the equation x squared minus 2x plus 1 is equal to 0. In this case, you write it in a curly brackets because it's the set, and you write a line which is read as such that. So x belongs to R such that x squared minus 2x plus 1 is equal to 0. Note that this set consists of one element 1. Using the same method, you can write all the integers from 1 to m. So you write that it's an integer such that 0 is less than n, and it's less or equal than m. So in this case, it's all the numbers from 1 to m. We also denoted it like this. Sometimes you don't know how to describe the elements of the set, but you know how to construct them in a constructive way. For example, you want to write a set of all perfect squares. You don't know how to check if something is a perfect square, but you know how to generate them. You just want to have a set of n squares such that n is an integer. Or you may list all the rational numbers. If you write it's a over b such that a and b are integers and b is non-zero, because we cannot divide by 0. In mathematics, we really like to compare objects, and the sets can be also comparable. So for example, we can say that two sets are equal if they have precisely the same objects. It doesn't matter how we describe the sets, they can be equal. For example, the set 1, 2, and the set described like this. So all real numbers x such that x minus 1 times x minus 2 is equal to 0. These two sets are equal because we may check that this equation only have 2 solutions, 1 and 2. So this set consists of only 2 elements, 1 and 2. Additionally, we may say that the set A is a subset of the set B if all the elements of A are also elements of B. For example, the set of integers is a subset of the set of reals because all integers are also reals. Or we can say that the set consisting of one element 1 is a subset of the set consisting of 1 and 2. We can also make some operations on the sets. The first of them is called union. So let's imagine that we have 2 sets, A and B, and we want to compute their union. In other words, we want to find the set that consists of elements of both sets. So something like this. So the union is just a set of all objects that belongs to either A or B, like in the picture. We denote it with a sign like cap. The next operation is intersection. So if you have 2 sets, A and B, the intersection is the set of all objects that belongs both sets. so this part. In other words, intersection of sets A and B is the set of all x such that x belongs to A and x belongs to B. We denote this set as A, the sign B. And the last operation is difference. The difference of two sets A and B is this part of the set A. So it's all the objects in A that doesn't belong to B. Note that this operation is not commutative, so A minus B is not the same as B minus A. A little bit more formally, the difference of A and B is a set of all x such that x belongs to A and x doesn't belong to B. We denote it using the backslash. In this video, we discuss sets and what kind of operation we can do on them. In the next video, we are going to discuss functions and, again, the operations on them. If you have any questions, ask them in the comments. See you later.